I am going to explain elasticity chapter. This is a chapter which is present in your syllabus. If you are in 11th standard, this is for you. If you are a student of a BSc and you have taken physics as honors, this is also for you. Let me explain what are we going to study. So I have told you our name of this lecture is elasticity and we will explore in details it. First, let me start with deforming force. Deforming force. We start this chapter with this word because we are starting from beginning. Deforming force means it is a force. We are familiar with force, but new word is coming, which is a deforming. This is a deforming, and I think you don't know meaning of deforming. If you don't know, I am here to explain it. Deforming means to demonstrate. Demonstrate of something. Something can be body, can be non-living thing body, living thing body, anything. When force is being applied on an object and object has changed its configuration. Sometimes you will see body didn't change its configuration. Both things can happen. When force will be applied, then both things can happen. And understand over here, just understand that okay, we will apply force on body and body can demonstrate or body cannot demonstrate. If a body is deforming by applying force, it means body has a, or you can say body is going to change its original configuration. That is what will happen when force will be applied. And this is what is our deforming force. Now next we have restoring force. Restoring force. Deforming force means demonstrating, and restoring force means look. It's all about objects, solids. When we say objects, so liquid will come and gases can come. But right now I am just taking an example of a solids. What will happen when we will apply a deforming force? Two things can happen. Either body will change its configuration or it can't change its configuration. It's a configuration. When body will change its original configuration, you will realize by nature, you will see that body is restoring its original configuration. Means body is regaining its original shape, original size. It happens in our world. It is a nature. And you know, physics is a deal of a nature. So here, body can regain its configuration. If a body is not regaining its configuration, we call it as a plasticity. But right now, just understand restoring means body is restoring what? Original configuration. Okay. After this, we are able to understand elasticity word. Elasticity word. Elasticity word. Two words were compulsory to understand elasticity. Okay. Now try to understand what is elasticity. Look, it is a property. It is a property of any object. Okay. Now what is the work of this property? It says when deforming, look, this deforming force will be removed. Eventually, we have applied a deforming force. And now we are saying, okay, we are going to remove deforming force. And body is restoring its original configuration. We can say it is happening due to elasticity property of the body. Okay, just restoring something is just restoring by the body. We can say body has an elasticity property. It happened due to elasticity property, which is the present in this body, and body can be solid, it can be gases, it can be liquid. Okay, next we have just opposite of it plasticity. Just opposite of it plasticity. In the case of a plasticity, you will observe that there are a lot of objects. Some objects will be able to restore its original configuration, which we say elasticity. But on the other side, in our world, we can say there are some more objects that are not able to regain its original configuration. Indirectly, we understand that those body who have what plasticity property. Due to this, they are not able. Due to this plasticity, they are not able to regain its original size or shape. Clear? In our world, these two things are happening in our world. But we just see, and if you are studying it, you will understand, you will interact that okay, this is a elastic. In this body is a elasticity property. This body is restoring its configuration. That is how you say with logic. You have what logic? Now next, once you have understood elasticity, plasticity, after this we understand stress. Not that state that comes in our life. No, it is a completely different from that in our this particular subject. It says that I am nothing but F upon A, and this is equal to pressure. This is equal to pressure. Again, I am telling you, we are in the context of physics, so don't think that this is a pressure which we say in our life. Okay. So stage means F upon A. From this F upon A, we can define this word which is the stage. It states that how much how much you have applied deforming force on per unit area. On per unit area, how much? Okay, and just opposite, you will see that this much what restoring force on that particular per unit area will be restored by the body, and from this equation we will get how much restoring force is being applied by the body on per unit area. This is what is our stress, and it is a formula for the pressure also. Okay, this is enough. Now next we have types of stress. Types of stress. There are few types of stress. First we have longitudinal. Second we have tangential. In longitudinal there are two more: tensile and compressive stress. Okay, one by one let me explain. Longitudinal means it is related to length. When we apply, let's suppose it is an example, and this is a object which is fixed with this roof, and we are going to apply force like this downward. What will happen? Initially was over here, and finally it came over here. Finally it came over here. Okay, so you are observing that we applied this much force, and this body will apply same force to regain its original configuration, and this is related to length. This is related to length. Length has increased, so this same length where it was present initially, it will come by this body when it will apply restoring force. Okay. So just understand longitudinal is related to length. Okay. Now next we have in the longitudinal stress, as I told you, there are two more which are tensile and compression. Tensile means a tension, not that tension. Okay, don't don't think like that. Tension means pulling force. This is a pulling force. Pulling force. Okay. Tension means just pulling, not pushing. And compressive means pushing, not pulling. Not pulling. In both cases, you will see there is a restoring situation. Restoring situation. Okay, so I hope you understood what is a tensile and what is a compressive. Tensile means tension, and compressive means compression. Got it. Now, volumetric. Volumetric stress. It is related to volume. Volumetric means volume. Means there is a body who has a shape, who has a what? A space. A space means volume. Body can have anything to keep anything. So volumetric is related to volume, and we apply on a volume solid. You will see that volume solid will apply restoring force to regain its original configuration. How much? F upon A. Formula is the same. For the types of stress, formula is the same. F upon A. Just understand longitudinal stress is related to length and volumetric stress is related to volume, and tensile is related to tangent. Tensile means we are going to apply tangent force. When tangent force will be applied, what will happen? That body will apply tangentially force to regain its what? Original shape and size. Okay? This was about the types of stress. Now we are able to understand the strain. Strain. There is a user difference, but both are linked. Between stress and strain, there is a user difference. Difference is, in this case, we just talk about the force upon area, but when it comes to strength, we realize what? Ratio of change in something, change in dimension, you can say, upon original dimension. Means our focus will be on change thing upon original thing. Okay, let us explain it one by one. So in this, you understood change in dimension of the body upon original shape. Clear? There are four, or you can say three types of strain. First, same longitudinal strain. Not I am saying longitudinal stress. I am saying longitudinal strain. Then tensile, then volumetric, then shear, tangential strain. Okay, it is a very interesting to understand it. Types of strain. First, we have longitudinal. Longitudinal strain. Again, I would say it is related to length. It is related to length. It will tell you how much length has changed. Change in length upon original length. Change in length upon original length. Because it is related to length. Okay. So next we have volumetric. Related to area we don't have in this particular chapter. Now volumetric strain. Since it is related to volume. So here you will say change in volume upon original volume of the body. When the foreign force was applied on the body, so how much it has a change in the terms of a volume. Okay, in the terms of a volume, and we compare this with the original dimension. Clear? Got it? Now next we have shear, or it is called tangential shear strain. Here you will see this is a phi, and it is equal to change in length upon original length. Both are not equal, brother. I can draw figure for this shear strain. It looks like this. Original was over here, and finally it came over here. But you will see that this bottom part of this body is fixed with the surface of the earth. But there is no attachment of anything with the top part of this body. And by the nature you will see that top part is moving. When the foreign force, or you can say tangent force was applied, then just top part of this body has changed, has displaced, because there is no attachment or fixed. If you see this bottom, it is fixed with the surface, and it can't move at all. At all. So how much theta it has rotated? This is what is our shear. Shear strain. How much it has displaced, or you can say rotated by the theta. Clear? Okay. Let me explain how did this change in length upon L came. It came. We consider this as a change in length, and this side of this line we consider it as a what length. Clear? Now we are going to connect all this to understand Hooke's law. To understand Hooke's law. So let me explain Hooke's law over here. Hooke's law, it states statement of this person was, and it is a valid even in our modern India, in our modern world. Explain statement of this person was according to this law, according to this law. But remember, we have to be within an elastic limit. If we cross a limit of elastic, then what will happen? We will see body is not able to regain. This is what will happen. So that's why it is a compulsory. If you want that this Hooke's law should be valid, then of course you will have to be within an elastic limit. Or you can say it is a warning or not. So let me come to the statement of this person. It explained that according to this law, stress which was produced by the body is directly proportional to strain produced by the body. This was the statement of Hooke's law. Are you able to understand? Means if stress is increasing, if stress is increasing, then strain will also increase constantly at the same time. At the same time, if you increase stress, you will see that by nature strain is also increasing. And this was the law of Hooke's person. We feel that it is very difficult, but once you understand, it becomes very easy because it is related to nature. It happens in our daily life, and we can visualize. We can visualize it. I know this is in the form of a text that are present in our book, and we are not able to visualize that much. But just once you understand feeling of this text, this word, then this is your duty to visualize by the nature, and it is happening in front of you. Okay, so finally, we convert a statement of this person into stress is directly proportional to strain. Clear? And you know that to remove what? To remove this directly proportionality, we use what? A constant, and that constant is this u. That constant is this u. Okay. So to remove this symbol, so stress is equal to E times strain. E times strain. And here E is the constant. E is the constant. It is known as a coefficient of elasticity or modulus of elasticity. I hope you will remember for the long time. So over here A is the constant. Got it? From this equation, you can get two more things. Which are, stress is equal to A times strain. Now E will be equal to what? Stress upon strain. Am I right? Okay. Yeah. This is one. This was one. This is second. Two equation you have got. Now, what about strain? To find out strain, this will be equal to what? Strain, okay, and this is stress upon A. Is that correct? Or you would say, let's say, if E was over here, E will come downward, and stress will be as it. Strain will be as it, and E will come downward. Clear? If you want to draw graph, because in this subject, graph is very important. or you can visualize from this graph. So let me draw graph for this Hooke's law. For this Hooke's law, graph will look like this, like this. This is horizontal, it is vertical, and we are taking this vertical as a stage, as a stage. We are considering this as a stage and this as a stem. This as a stem. Now, according to this law, we are saying if stage will increase, then stem will increase automatically. Means E is a constant. A is a constant. This is E, and it is a tan theta, and this is a slope. This is a slope. Tan theta provides a constant thing, and slope is known as a constant. Clear? What are you understanding by this figure, by this graph? What are you understanding? You are understanding that if we decrease this stage, then strain will decrease automatically, even by nature. Even by nature. And this line is nothing but it is a elasticity, modulus of elasticity, or you can say coefficient of elasticity. Coefficient is what? Constant number. Clear? That's it. I hope you understood a lot of things from this little lecture. And name of this lecture was elasticity. Okay. After this, we understand what? We understand the relation between modulus of elasticity. Even I didn't explain modulus of elasticity. Yeah, I have explained modulus of elasticity, but I didn't explain types of modulus of elasticity. In another lecture, I will explain. This was enough for your basic.